Hello. Okay, thank you. Just we're waiting some minute, then we'll start.
Evening,
Yeah,
sir.
yeah. Yeah, good evening. So we'll start this session. And after completing the 3 hours live training program, then we talk about the problem solving class. So basically today's session I can discuss about that machine learning algorithm, how we can really apply in Google Earth Engine. And then further we can do the different types of classification work. Yeah. So let me share my screen. Okay, now can you see my screen? Is it visible?
Yes, sir. Visible, sir.
Okay, so basically today is our sixth number class, and mainly today I talk about that how we can easily work with the machine learning in Google Earth Engine. We can easily apply the different types of machine learning, such as supervised, unsupervised. So this type of machine learning model, how we can easily apply in Google Earth Engine, and further we also try to make suppose land use land cover map using machine learning. Okay, supervised, unsupervised. Okay, a lot of things I also try to explain in this section, as well as in the supervised learning, basically random forest algorithm or cart model, mainly classification and regression model, then support vector machine model or minimum distance, this type of method or algorithm, how we can easily apply, okay, and make the land use land cover map. We also already discussed about that, and how to check the accuracy assessment of land use land cover mapping, such as overall accuracy, kappa accuracy, producer accuracy, or consumer accuracy, how we can easily calculate. We also discuss about that, and how to calculate the land use land cover classes area, okay, and how to add the legend or land use land cover map, and finally how we can easily export this land use land cover map and use the ArcMap software to make the proper map layout. So all of those things we try to explain one by one. So let's go. So basically, in this time, we just apply the machine learning in Art Engine platform. Okay. So actually, when you use the Art Engine platform for machine learning, we can freely use the machine learning in Art Engine. But when you want to apply the deep learning, basically CNN or ANN, so this type of deep learning model is not freely available in Google Earth Engine. Okay, but machine learning algorithm such as random forest or classification regression trees or support vector machine or minimum distance. Okay, so this type of machine learning model is available freely. We can use in Google Earth Engine and apply the different types of machine learning model. Okay, but deep learning, when you want to work using Google Earth Engine, then you have to pay. Okay, and they are buy their cloud storage, and then you can easily use the deep learning model. Okay, so that's why you are not talk about the deep learning in this time. So in this time, we are just concerned about that only for the machine learning, supervised, unsupervised. These two types of machine learning algorithm, how we can easily apply in Google Earth Engine and make the different types of classification work. So basically, we find out the supervised, unsupervised, and regression. Okay, these three method or three machine learning model we can apply in Google Earth Engine freely. Okay, supervised classification, unsupervised classification, and regression. So now I try to explain about that. What is the supervised, what is the unsupervised, and what is the regression. So basically, supervised classification, one of machine learning technique for classifying land is to use the ground truth example to teach a model to differentiate between classes. And Earth engines have the built-in supervised classifier. Okay, so in this time, if you need the random forest, it already built in. If you need the support vector machine, it already built in Earth engine. This type of built-in supervised classifier, such as random forest, cart, support vector machine, minimum distance, so it already available in Earth engine platform. We can easily use it, this type of things. And the supervised learning, so basically when you want to use the supervised learning, you must need to ground truth data or training sample. Okay, so we need to teach a model to differentiate between classes. So I need to teach, this is the water, this is the build up, this is the vegetation or forest. Okay, I need to teach my model. Okay, when I work with the supervised classification. Okay, but when you apply the unsupervised classification, then no, don't need this type of ground truth example or training sample, or don't need to teach a model to differentiate between classes. It's not need when you apply the unsupervised classification. But supervised classification, you must need the training sample or training data to teach a model to differentiate between classes. You need to take the training sample for water body, vegetation, build up, or urban. Okay, so which class you want to classify, you must need the training sample or ground truth data when you apply the supervised learning. But
Voice is not
yeah,
coming properly.
okay, can you, okay, I think some networking issue, just a minute. Okay, now can you hear me now properly? Hello.
Yeah, yes, sir.
Okay.
Yes, sir.
Okay. Okay, so basically, this is the basic difference between the supervised and unsupervised. So, unsupervised classification, it's one kind of machine learning algorithm for classifying land use and land cover classes using ground truth data. And this ground truth data or training sample to teach a model to differentiate between classes. Okay, but unsupervised classification don't need this type of ground truth data. Okay, don't need any kinds of training sample. Okay, it don't need any kinds of training sample or ground truth data. Don't need. We are just applying the unsupervised learning. Then it find out the similarity. Okay, it find out the similarity and make the classes. Okay, and regression mainly it find out that linear regression model. Okay, suppose and predict the different types of cloud cover or crop yield prediction. We also do also water quality or present forest cover. So it's also possible using the regression. Okay, so previous class I also discussed about the one regression, but we are using the mainly Python code. Okay, and find out the regression. But this type of regression is also possible to use in Art Engine platform. So supervised, unsupervised, and regression, these three things we can easily apply in Google Earth Engine and also work with that. So let's go one by one. We try to check about the practical example. Then we also get the more better idea. So now, what is the classifier? Okay. So basically, which algorithm you implement in your model on your data set is just called as a classifier. Okay. Suppose if I use the random forest in my data and I classify, then my classifier is random forest. So actually, which algorithm you want to implement the classification on a data set is known as the classifier. The classifier, it can be random forest or super vector machine. Different types of classifier is available in Google Earth Engine. And there are the two types of classification. Basically, you find out the binary classifier and multi-class classifier. Suppose binary classifier only for the two outcome. In the binary classifier, you find out the only for the two possible outcome. It's called the binary classifier. Suppose yes or no, male or female, spam or not spam, cat or dog, forestation or deforestation. So possible outcome only for the two. Okay, so possible outcome only for the two. That's why it's called the binary classifier. Okay, I think some network issue. Just a minute. That's why it is buffering sometime. Okay, just a minute. Okay, now can you hear me? Hello.
Yes, please.
Okay, okay, thank you. Okay. Okay, so now we talk about the classifier. So basically, which algorithm we implement in our dataset, it just called as a classifier. And we find out the two types of classifier. One is the binary classifier, another is the multi-class classifier. So basically, binary classifier, the possible outcome of the problem only for the two outcome when it can got, it's called the binary classifier. Such as yes or no, male or female, spam or not spam. And multi-class classifier, we find out that more than two outcome. Okay, such as land use, land cover, more than two outcome. Suppose at the same time you want to classify for water body, build up, vegetation or crop plant at the same time. Okay, or crop types, so different types of crop, rice, sugar cane, jute, or classification of types of music. So more than two possible outcome when you got it called the multi-class classifier. So now what the process to make land cover classification map in Google Earth Engine? So first of all, you need to selecting your study area. Okay, suppose which area you want to make the land use land cover mapping, simply import your study area, and then you can easily make you can easily import your shape file. Okay, and then you can easily get these things from Google Earth Engine. Okay, and further if you want, then first then you need to choose the image collection. Okay, so you need to choose the image collection. So in this time, if you want, you can choose the Lancet or Sentinel. Okay, so both are images are the same process. You can simply choose your image collection. So his image you want to use. Lancet and Sentinel both are the same process when you want to make the classification. Okay, and further we need to also work collecting the training point. Suppose in this time I want to make the land use land cover map using supervised machine learning model. So that's why you need to collecting the training sample. Okay, you need to collecting the training sample, and further you also need to make the training merge the training point. So all of training points simply merge together. Okay, and after that just simply make a training data set by sample regions. So in this time we are just simply extract the different types of band pixel value. Okay, different types of index pixel value simply extract from here, and then this data set we simply spill the two way. Suppose some data set I want to use to train my model, and some data set I want to use to check the validation or accuracy. Okay, just we simply spill the data set, and further just create the classifier. In this time if you want, you can use here the random forest or support vector machine or any other classifier. Simply create the classifier and classify the image, and then create the classified image, then display the result and print confidence matrix for your accuracy, taking the accuracy assessment. And further just calculate the area all of classes. We simply do it. And okay, so basically this is the overall process. So first of all you need to selecting your study area, then choosing and filtering the image collection. Just choose and filter. So in this time you choose the Lancet or Sentinel or any other satellite image, you can simply choose, and further you can simply put it. Okay, and then collecting the training point. Okay, and then merge all of training point together. Simply merge all of training point together, and then make the training data set by sample regions. Okay, okay, I think some networking issue. Just a minute. Okay, now now it's okay. Can you hear me? Hello.
Actually, sir, it is voice is being frequent, sir.
Okay, just a minute. Okay, so now this is the process. So first step, we simply select our study area, which area you want to make the land use land cover map. Second step, just simply choose and filter your image collection. You can simply choose the Lancer or Sentinel, anyone. Both are the same process. And then collecting the training point, because in this time we are applying the supervised learning. So that's why you need to collecting the training point. Then merge all of training point together and make a training data set by sample regions function and create the classifier. So let's go practically. We try to discuss one by one. So let me open my code editor. This network is very bad. Okay, so first step, simply import your study area. So just simply import your study area. Suppose in this case, just I simply import the study area. Bangladesh district boundary simply store. And further from here, I simply choose the specific boundary, suppose district boundary, and make the land use land cover map. Okay, just take a variable, suppose ROI, and then call the table, and I want to filter it, this table. So put here e dot filter dot equal. So now put here the column name 2. This is the attribute column name, and then I put here that suppose wrongful. Okay, and further I want to display my study area. Just add a layer, map dot add layer, and then put here the ROI. Okay, so now further also focus the center of this boundary shapefile of ROI. So map dot center object is ROI, zoom level suppose 10, and click run. So now it display your study area. Suppose this is my study area. I want to make the land use land cover map for this boundary. Okay, so this is my study area. So simply this is our first step. Okay, this is our first step. Just simply import your study area, which area you want to make the land use land cover mapping. Okay, so after doing these things, second step, mainly for the second step, we are just choosing and filtering the image collection. Okay, so if you want, you can use it at the Landsat, or if you want, you can also use it at the Sentinel. Okay, both are the same process for Landsat or Sentinel. Landsat is 30-meter resolution, Sentinel is the 10-meter resolution. But when you want to make the historical land use land cover analysis, then you must need to use the Landsat imagery. Okay, but for the present time, you want to make the analysis, then Sentinel is more better than Landsat, because Sentinel is high resolution than Landsat satellite imagery. So in this case, I simply open my image collection. Just go to the browse data catalog. And I want to suppose Landsat Sentinel. I want to use suppose Sentinel. Okay. So you also try to use Landsat imagery, because this is the same process. Just apply also Landsat imagery. So in this case, I want to apply the Sentinel to satellite imagery. Okay, this is Sentinel collection, and I want to use Sentinel to multispectral instrument. And here we find out the two types of satellite imagery: surface reflectance and top of atmosphere reflectance. So basically, surface reflectance satellite imagery, it used for making the land use land cover mapping. Okay, so when you want to make the land use land cover mapping, just try to use the surface reflectance satellite imagery. So just click on the surface reflectance. So here you can got all of things. Here you can see the surface multi-spectrum instrument level 2A data. So this data set is availability from year of 2017 from 2024. Okay, and this is the data set provided in European Union ES Copernicus, and this is the unique idea about this data set. Okay, so in this time I want to use this satellite imagery and make the classification using machine learning model. Okay, so just simply copy this, choose your image collection. I choose the Sentinel, and further this image collection I want to filter. So this is our second step. Choose and filter image collection. Okay, then simply paste here this ID and give a variable name, suppose image. So now this is my image collection. This image collection I want to filter. Okay, so we already know about the different types of process for filtering. Okay, so previous classes I also did discuss a lot of time for different way for filtering the image collection. We can apply anyway. Okay, so first of all we need to apply the put here the filter bounds function. Put here that filter bounds in interaction with our ROI, which stored the Rangpur district boundary shapefile. It stored the ROI. So just put here the ROI. Okay, and further put here the filter metadata. So basically in this case we put filter the image properties. Suppose I need this image less than 1% cloud cover. So simply copy the image properties. From here you can see the image properties. Cloud pixel percentage. Just copy and then paste here. And then use that less than suppose 1. Okay. And I want to use suppose image in 2024 imagery. So just put at the time, suppose 2024 1st January from year of 2024, suppose 06, suppose 30. Okay, so between this time period I want to check how much image is available. Suppose print this image and click to run. So now it's computing between this time period how much image is available for my study area. So we can easily get it from here. You can see console tab. We find out the 16 images. Okay, so if you want you can make the land use land cover only for the single date image. It also possible, or if you want you can make the median composite or mosaic composite and also make the land use land cover mapping. Okay, so basically it's depend on your research work. Sometimes we are using the median composite and make the land use land cover mapping. Sometimes we are just only use the single date satellite imagery and make the land use land cover mapping. Suppose in this case I will show you that how we can easily use the single date imagery and make the land use land cover mapping. So here we find out the total 16 images. Here you can see. So from these 16 images, I want to use only for the single date imagery. So here you can see there are all of images available, and all images are the less than 1% cloud cover. Okay, all images are the less than 1% cloud cover. Suppose here you can see this is the one image in year of 2023 0309 9 March. We find out that one imagery. Just click on here. Suppose I want to use this image in my work. Okay, single image I want to use. So for that, simply copy this ID. So here you can see this imagery have a ID. So simply copy this ID. Okay, simply copy this ID of this imagery. Copy, just copy. Okay, copy. So now we choose only for the single date imagery. And if you want to check all of information for this imagery, suppose you need all of information, just click on the properties. Then you can get all of information. Here you can see all of information about your image. We can easily get it from here. Such as you can see the cloud pixel percentage, how much. Okay. Also you can see the cloud coverage assessment, how much. Okay. Cloud shadow percentage. Okay. All of information for your single date imagery. We can easily get it from here. Also you can see about that image acquisition date. Okay. All of those things we can easily get it from here. You can see There's a lot of
Excuse me,
information.
sir. Why did you pick image?
Which one?
Excuse me. Why did you pick image 9? Because your sound went off. We couldn't hear you.
Okay, so it's a single
Why
date
did you pick
imagery.
number
We
9?
can we can use any imagery. There is no problem.
Okay.
So basically, we can create the single date imagery or median composite imagery. Sometime we are using the single date imagery and make the land use land cover mapping. Sometime we are just make the median composite. Okay, we already know about that how we can easily make the median composite. So basically, just I take the median function and create the using the total 16 images and make the median composite. Okay, any image and all of images are the same less than 1% cloud cover. Okay, total 16 images we find out. Suppose I simply choose the one, suppose 9. Okay, please. Anyone, any question, please? Please.
Yes. Why didn't we use the median composite?
Median composite need when you want to apply it for the big study area. Okay, suppose single tiles is not enough fully cover your study area, then we have to use the median composite. Suppose you want to make the land use land cover map for the whole country boundary of Bangladesh, so then one tiles is not enough, one image is not enough to cover the full study area, then we have to use the median and then it fully cover my full big study area. But for the small study area, when you want to use, then you can easily use the single date imagery. Okay, then easily fill up my study area and we can easily get the result. Okay, but for the big study area, when you want to work, you must use the composite. It can be median composite or mosaic composite. But without composite, it cannot be fully fill up your study area. But for a small study area, we can easily apply the single acquisition date satellite imagery. Yes, please.
Sir, what is the difference between the median composite and mosaic composite?
Okay, so median composite, it take the middle pixel value, all of images and create this composite. And mosaic, it not take any kinds of middle pixel value, just marks with your study area, just marks, just marksing and clip your study area. But median, it take the middle pixel value. Okay.
Okay.
Suppose this 16 images, I want to apply the mosaic. So then this 16 images create the marks and mosaic for my study area. Okay, but when I apply the median, then it take the middle pixel value from all of images and make this composite. Okay, but when I just use the singlet imagery, then we are not applying any kinds of composite. Just we take the single acquisition date satellite imagery and make our analysis. Okay, so median is also need some region. Suppose when you want to apply it for the big study area and your one imagery or one tiles is not enough fully fill up your study area, then we have to use the median or mosaic composite. But a small study area, we can easily choose the single satellite imagery and we can easily work with that. Okay, any question, please?
Sir,
Yeah,
under
please.
the ban, I saw under the ban in the console section. I saw like unsigned integer and signed integer. What is the difference between unsigned integer and signed integer? Yes, under that ban, could you
Yeah.
please click it?
So just it show the unsigned integer 16, and so basically it's the band one, it unsigned. Basically in this time this band in this time we are not applying in here, but when I sign it, suppose I just show the make the imagery with clip with my study area, then it not show this type of unsigned is not showing. Okay, but in this time this image is okay, but this image we are not clipping with our study area yet, so that's why it show the unsigned. Okay, but when I clipping with my study area and visualize, then it not show the it just only show the band name b1 b2 b3, this type of band name showing. Okay, when I just apply it and clipping with my study area. Okay, so let's go try to apply this id. So simply copy this image id, which image you want to apply, just simply copy this id, simply copy and then just take a variable. Suppose I put the variable name is that I put the variable name, suppose new image. Okay, and put here ee dot image and paste this ID. Okay, just paste this ID in here. So in this case, I just choose the single date imagery, and further I want to visualize the image first. Suppose just try to add here map dot add layer and call this new image and paste it. So now it visualize, okay, without clipping. Without clipping, you can see it, we got this type of result. Okay, but this imagery, these styles have a problem. Here you can see these styles is not fully fill up my study area. Okay, you can see some part are not fill up, so this part is not fill up, so that's why I cannot use the styles. So I need to find out the other single date imagery. So let's go try to find out other single date imagery which is fully fill up my study area. So let's go. So further I try to click on here and click on the feature. So let me try suppose this imagery. Acquisition date 2024, 4th January. Okay, just copy this ID and replace. Just change it. Just I change it. Just paste here and click to the run. So now let's check what happened for this imagery. 4th January. It's also not fill up. So you can see it's fill up only for this part, but other part is not fully fill up. So now let's check the other imagery. So basically we use the single date imagery which image is fully overlay with my study area. I just use it. Okay, otherwise it not work. So we try to find out this imagery one by one. This imagery is fully fill up my study area. So let me try for other. Suppose I just use here the free, just copy this ID. Copy this ID. And further this ID I replace and then check what happened. If I use the median, then this type of is not need. Just I use the median, it easily fill up my whole study area. In this case, we try to find out the single date imagery and which imagery is fully overlay with my study area. I want to find out this imagery and then I want to use it for my study area. Okay, it's also same. It also not fill up. I try to use it. And then check what happened. Click to the run. Same. So this is the problem. Okay, and when you want to apply it for the more big study area, we also face this type of problem. So that's why we are also use the median function. Just make the mosaic. Yes, please. Any question, please?
So in the median function, what the function does it that it sort of uses more than two or three images to make a composite image which covers everything.
Yes. So this is the better way. We can just create the median composite, then it easily fill up. But some purpose, some different purpose, we also need to use the single satellite imagery. Okay. So that's why I also try to show you that how we can easily find out the single date satellite imagery. But it also more better. We can easily get it using the median. Suppose if I just create the median, then it easily fill up my whole study area, and we can easily get the composite satellite composite.
So in time, you have to only use this trial and error method.
Okay, it also not fill up. Some part is the missing also. Okay, it also not fill up. Okay. But one image will be fill up because it's not much big study area. So you have to check it carefully, all of images one by one. Then it also fill up, I think. Okay, it also not fill up. Okay, it also not fill up. So I think it also better to use the median composite. Okay. So for that, you also try to check sometime for your study area. If you don't find the singlet imagery, then you can directly use the median composite or mosaic composite. Okay, so let's go try to apply the median. So for the median, just put here the dot median. Okay, and first of all, I try to run this code. Okay, just I call the image. Okay, just put here. Then now check what happened. If the fully fill up or not. Okay, so now it's fully fill up my study area. When I apply the median, you can see it just fully fill up my study area. Now I just use the clip function to just apply the clip. Okay, just clip. And then clip with my study ROI. So now we got the image only for this my boundary area. Okay. So this is my satellite imagery between this time period 2001st January to 6. We find out the total 16 images. And when you can see we can got this type of things. In this time here you can see there is show the double, not show the unsigned. Okay, because in this case just I clip with my study area and make the imagery median imagery. Okay, so in this case we also need to rescaling the band pixel value or a spectral signature value. We need to rescaling the band values. So for rescaling the band values, they are already provide the scale. Here you can see basically it is the new update method. They are also put the scale. And when I put the rescaling using this value, then we put the proper spectral value. Okay, proper spectral signature values for each properties or each classes. So that's why we are just simply multiply this scale value with our imagery. So just after the imagery, just use here the dot multiply function, multiply and apply multiply. Okay, then we can get the proper spectral signature value. Okay, after multiply. So here you can see we got this type of bands. Okay, so now it show about the 0 to 6.5. Okay, it show the proper range about this is band, as well as when I just click on here and add the band combination. Suppose add here red, then put here the green and blue color. So it's the RGB or natural color band combination. We are apply and just apply in here. And further just import. And after importing, just copy this variable name and paste. After the layer name, I put it, it's a image. Okay, so this is my satellite image. So now this image I want to make the classification using machine learning model. Okay, so here you can see this is my imagery, satellite imagery. In this case, we create the median composite, but if you want, you can also use that the single date imagery. It also okay. But in this case, we are not find the single date imagery, or you also try more. Then I hope you can also get one by one. You can check all of images. Suppose total 16 images you can get. So all of images single by 1 to 16, all of images. Just check the ID, which imagery fully fill up your study area. Then you can use the single date imagery. Okay, or if you want, you can directly use the median composite and then create this type of median composite imagery. Okay, and this imagery composite less than 1% cloud cover, because I put here the 1%, less than 1%. Less than 1%, we find out the total 16 images. We are just use all of images middle pixel value and create this composite. So now from this image, I want to make the classification. Okay, I want to make the classification. So now, first of all, we need to define which class I want to make the classified. Okay, suppose I in this from this satellite imagery, I want to find out suppose this type of class I want to classify. Suppose I want to classify suppose water body from this satellite imagery. Then I want to make the classification for build up area. Okay, then I want to classify suppose Maryland. Okay, then I want to suppose classify suppose vegetation as well as I also want to classify suppose cropland or agricultural land or cropland. So this is my total 5 classes I want to classify from this satellite imagery and make the land use land cover classification map. So in this case, we are applying the supervised machine learning model. And supervised machine learning model, I need to teach my model. This is the water body sample. This is the build-up sample. This is the barren land sample. This is the vegetation sample. This is the cropland sample. Okay, I need to teach this model because it's a supervised learning. I need to supervise my model. This is the build up, this is the water body, this is the vegetation, this is the cropland. And when I teach my model easily predict from this all of area and then show the all of water body, show all of vegetation, show all of build up, show all of barren land, show all of cropland. Okay, because it's a supervised learning model. So now how I can find out the water body from my satellite imagery, how I can find out the build-up, how I can find out the vegetation, barren land, and cropland. In this time, we are applying the different types of band combination. So we are using the different types of band combination and then try to find out the different types of feature from this satellite imagery. Suppose I want to use a band combination. In this case, it's called the RGB band combination. Yeah, RGB mainly it's the natural color. Okay, natural color what human eye can see naturally. Naturally, we find out the vegetation as a green color. Okay, we can easily find out it's a we can. I'll also zoom it. Suppose just zoom. Then we can easily get it. This type of place we have some build up. You can see this type of build up area. You can also find in here. Okay, as well as we also get this type of region here. You can see. So it's a naturally we can find out this type of build up. It's a build up or settlement. It's a settlement. We can easily find out from here. And this type of green color indicating about that vegetation or cropland. Okay, we also get this type of place. Okay, also you can get this type. You can see this is the river bank or it's a barren land. Okay, and we also get this is the river water body. You can see this place. So naturally what human eye can see. Okay, so it's the natural because I put here the RGB color. Okay, as well as if I change the band combination, suppose I want to apply the false color band composite. So this band composite is that when I apply, just click on here. Suppose I want to put here the near infrared band. Basically, near infrared band is the B8 for sentinel imagery, near infrared. Then put here that red and blue. Custom stressing, suppose 98%, and then apply. So in this case, vegetation show as a red color. Okay, we find out that red color indicating the vegetation, and water body show as a black color or dark color. So here you can see this type of water body. So it's a one kind of water body. Here you can see, if I just zoom, then we can easily get it. It's a water body. Water body show as a dark color or black color. You can see it's a black color. Okay, it's a black color or dark color. So all of black color, so indicating the water body. So here you can see it's a black color. So it's a water body. Okay, you can see it's a water body. It's a water body. It's also river or water body. Okay, we can easily get it. So this is the band combination, mainly near infrared, red and blue. Near infrared, red and blue, when you apply all time for any region, we got the water body as a black color, vegetation as a red color. Okay, so better vegetation show as a red color. And suppose this type of is the cropland area, we can find out the more visited area. So it's a cropland. And other vegetation, suppose trees or natural trees, so it's indicating about the trees or other vegetation. But this type of red color indicating as a cropland or agricultural land. Okay, we can easily find out from the satellite imagery when I apply this type of band combination. And it's a unique for any study area in the world. When you apply the near infrared, red and blue color band combination, we got this type of visualization for any study area. Okay, so this is the one. You find out that, as well as if you want, you can also apply, suppose just put here the short wave infrared one, then put here the near infrared band, near infrared, and put here the green. Okay, stressing suppose 98%. So now it also another band combination. We can easily find out the vegetation and cropland using this band combination. So here you can see we got this type of color, and water body show as a black color or dark color, as well as it also reflected the barren land. Okay, so this type of color, you can see this type of gray color, indicating about the barren land. So it's a barren land, it's a gray color. You can see this type of gray color indicating about the barren land. Okay, we can easily find out the barren land from here. Okay, and this type of things is the cropland. Okay, this type of green color, cropland, and other this type of green color indicating about that trees. Okay, or vegetation. And this type of color, this type of green indicating about that agricultural land. Okay, you can see this type of color indicating the agricultural land. This type of field, agricultural field. Okay, and water body show as a black color or dark color. Not only for that, lot of band combination is available. If I simply search on the Google, suppose Landsat 8 band combination or Sentinel 2 band combination, simply search, then you can easily get the lot of website. They are provide this type of information, and from here we can easily get the use the different types of band combination and identify the different types of feature. So here you can see this is the natural color 432, mainly red, green and blue, and it also applicable for the Landsat and Sentinel both imagery. Okay, for the Landsat Sentinel both are the same for band combination. Just put the red, green and blue band, then we can got this type of color. Okay, so here we find out the healthy vegetation is the green, unhealthy flora is the brown, urban feature appears as the white, okay, and gray, and water is a dark blue or black. Okay, here we apply the natural color 4, 3 and 2. As well as you can also see about the another 5, 4, 3, near infrared red and and green. Then we can get the, you can see the we can easily find out that vegetation. Okay, better vegetation have the red, have the better vegetation or healthy vegetation. Dark areas are the water, urban areas are white. We can get this type of color. Okay, and it's a unique for any study area you can apply. So this is another band combination. As well also you can see this is another band combination. Agricultural land, when you identify. So agricultural land, we find out the shape, rectangle shape or square shape. We find out this in this type of shape. But vegetation area, it not have any kinds of shape. It randomly distributed. But agricultural land have a shape. It can be a square shape or rectangle shape. Okay, and water board we can easily choose from here. So here you can see there are a lot of band combination, also geological feature. To identify the geological formation, lithology formation or fault, we can easily use this type of band combination. Or as well as also bathymetry. Okay, bathymetric we can easily put the 431, mainly red, green, and coastal band. Then we can pick into the water. We can easily useful for the coastal or bathymetric or aerosol studies. Okay, it reflects the blues and violet. Then we can easily get estimating the suspended sediment. It also use this type of band combination. Okay, as well as vegetation index. We already know about that NDVI or EVI. Okay, we can easily indicating the vegetation. Okay, so this type of NDVI we also input further later in our model for make the land use land cover mapping. I will show you that. Also, you can see moisture index. So this is the information for the band combination. So in this time, what is my target? My target is that for my machine learning model, I need the trained sample. Okay, I need the data. Okay, so now I want to put the training data. Okay, so let's go try to set the data, and I just take the training sample for each classes. Which class I want to make the classifier. So how I can take the class? So for taking the class, just click on the marker. Here you can see the marker. And further, you can see it show the geometry. Just click on the edit layer properties and name. Suppose I take the training sample for waterboarding. Just put here the water and import as feature collection property. Set the property, suppose class, and I set the value for 0. Okay, value mainly level. Okay, I set the level water is 0. All of training points I consider the level as a 0. 0 means water class. 0 means water class. Okay, just I click to the OK, and further just simply take the water body. We already know about that this type of place have the water. Okay, black color. So just take the training sample for water. Just take this type of training sample for the water. Okay. And now how much training sample I take for each classes? So basically it's depend on your accuracy. Okay, suppose you don't, suppose you get the very low accuracy, then further you also need to increase the training sample. But first time you try to take the training sample more than 30. Okay, more than 30 take and then run your model. And after checking the accuracy, if you don't get the more better accuracy, then also recheck your training sample, increasing or decreasing. Okay, suppose in this time I can easily identify this is the water body. I simply take this training sample as a water body from here. Okay, so now what happened? So now this type of water, this type of point extract the band pixel value. Okay, so different types of band pixel value it extract. And for every classes, suppose water band pixel value is the unique, vegetation band pixel value is the unique, and build up band pixel value is the unique. So every classes band pixel value are the unique. Okay, it's not the similar. So that's why we are just applying this type of things in the machine learning model. Further, from the whole imagery, machine learning model can be predict. This is the water, this is the vegetation, this is the build up, easily predict. When I just teach, in this time, I just take the training sample to teach my model. Okay, I teach my model. This is the water. This is the water pixel. So that's why I take the training sample. Okay, so I try to take more than suppose 30 or 31. Okay, so I just put this type of thing. So just I take only for this place. I put the water body. But when I apply the model, it easily predict for whole imagery where I have water. Okay, so in this case, I just take the training sample only for this place. But when I apply it in machine learning and apply it for the whole imagery, then whole imagery it predict where the water have. Just find out the water body, all of water body. Okay, so this is the water body. Then I take the another. Suppose I want to predict for suppose agricultural land. So just I put in here or cropland. Just I put here it's a cropland and feature collection, and I put here the class and set the value for 1. So all of cropland class or training sample I consider as the 1. Okay, 1 means cropland. Just I put the OK. And further I take the training sample from this type of green color pixel because it's a agricultural land. Okay, just I take. And then it easily predict for other place also as a cropland. Okay, I just put this type of way. Okay, and then further I want to take the training sample for vegetation. Okay, without cropland, but it's a vegetation. So let's go try to take the another new layer and put here vegetation. Okay, without cropland, mainly trees or other forest, other things. Just put the feature collection property. I set the property suppose class and set the value for 2. Okay, so now it's a cropland, so we are not considering this time this type of green color. Without this type of green color, we try to take this training sample. Okay, so just simply zoom. This type of, okay, it can be trees or other types of vegetation, but it's not the cropland. Okay, cropland is the better green color. This time we can get it when I use this type of band combination. In this case, I just take only for the one band combination, but when you want to work for the real project, you try to check more and more. You try to check the different types of band combination and check the feature. Yes, please.
Sir, I have a question. If I mistake to collect any kind of collection, then what can I
Okay,
remove
so
it?
for that, simply suppose I take it for water, mistake. It's a vegetation. So for that, simply click on the exit and then click on here. You can also delete. You can see the delete button. Or if you can simply move, just simply move and put the proper place. Suppose I just put in here. And then suppose I can click on the vegetation and take this training sample again.
Okay.
Type of things as a vegetation area or vegetated area. And further, we also try to take the training sample for barren land. Just click on here. Then just put here barren land. And then feature collection property, put here the class and set the value 0, 1, 2, 3. Okay. So basically we put the serially 0, then 1, then 2, and 3. So barren land. So basically this type of gray color, we find out this type of things here. You can see this type of, you can easily get it's this type of things as a gray color. We will take this type of environment. I think some networking issue. Just a minute. A lot of problem. And finally, take this training sample for suppose build up. So we can easily find out the build up ET. And for the build up, we just try to change it. Suppose we just put here the natural color. Okay, then we can easily find out the build up region. For natural color, we put here red, green, and blue. 98% and apply. So now this type of plus indicating the build up. So here you can see the build up. Okay. So for that, just take the new layer and put here the build up. Import as feature collection. Put the property, suppose class, and set the value for 4. Okay. So basically, you can see we start 0, 1, 2, 3, and 4. So now take this type of pixel, simply zoom again. So this is the build up. We take the pixel from here. For an example. And this is the road. Okay, road is also one kind of build up. or settlement. Consider it. This type of flag. Okay, so we take this type of build-up area. Okay. Suppose in this case, I want to classify for water body, cropland, vegetation, barrel and build-up. So just I put this type of training point because it's a supervised. So that's why I just supervise this type of training way. So now our after taking the training sample, all of classes. So this is our take the training points, and it's our third step. Third step. So now fourth step. Basically, we are just merge all of training sample together. Fourth step, merge. For merge all of training sample, just take a variable, suppose sample, and in this variable, I just store all of points together. Okay, just merge. For merging, just take the variable water, it merge with upland, then merge with vegetation, then merge with fairland, then merge with build up. Okay, so all of classes we simply merge together and store it in this variable samples. So if I just simply print this samples and run it, so now it computed how much training point I take for all of classes. Okay, it make these things. So now you can see computing how much class we got. Total 189. Okay, so 189 training point we put in our model, and you can see I make the pre-categorize. Okay, so this 189 points have pre-categorized. So here you can see all of point list. Suppose I simply check it. You can check it. This is the property class 2. Okay, so I set the label. Okay, this training point I use for class 2. And what is the class 2? Class 2 is that you can see 0, 1, 2 vegetation. So this training sample I use for take the training pixel value for vegetation. So every training points adding with their label. You can see adding with their label. So this is the class 3. So basically we already put the label. Water is the 0, then 1, then 2, then 3, and build up is the 4. So every training sample we make the label. It's called the pre-categorize. So we make the categorize. 0 is water, 1 is cropland, 2 is vegetation, 3 is barrelland, 4 is build up. We make the pre-categorize. Okay. So this is the one condition for machine learning or supervised learning. Okay, supervised learning, you must need the training sample or ground truth data. In this time, suppose this type of data. So basically, when you do for real project for crop classification, then we simply visit our crop area and then we collect the training sample. Mainly we collect the GPS location for each crop. Suppose rice, jute, sugarcane field, we visit it and take the random training sample for rice, sugarcane, and jute. And further, this type of training sample we simply import in our Google Earth engine and make the crop classification map. So this type of training sample we can also collect from the field and also work with Google Earth engine. As well as if you want, you can also use the different types of band combination, and then you can also take this type of training sample. Okay, which I show you in this time. Yes, please. Yes. Please.
Thank you, sir. Would it be possible to demonstrate, importing training samples if you have maybe an example?
Okay, I will show you that. No problem. Okay, I will show you that. Okay, I will show you that.
Thank you. Thanks.
Okay, so in this case, this is the same process. Also importing the training sample from the CSV file. Suppose if you have the CSV file, this CSV file, in this case, suppose I want to collect some training sample from my field, suppose for water or cropland or vegetation or parallel land or build up. So each classes you have to create the separate CSV file. Suppose for the water body, you make the one CSV file, which is including the specific latitude and longitude. Okay, latitude and longitude. Further, this thing we simply import in our Google Earth engine. Okay, so for that, what we can do, just simply click on the new button and then click on the CSV file. And CSV file, simply put your file for water body or agriculture. This CSV file. Suppose randomly I choose one file. Suppose I choose my, okay, so let me check. Suppose CSV file, where is it? This is longitude. Suppose this is my file for water body. Okay, this is file for water body. I simply choose it. And further, I click on the add property option. Okay, you can see it also have the add property option. So just click on the add property and put the property name, suppose class, and I set the value for water, suppose 0. Okay, and then you can also mention about that X column and Y column. Okay, so X column mainly your longitude column name, Y column is the latitude column name. Okay, so longitude and latitude column name simply put in here, column name. Latitude or longitude column name just put in here from your CSV file. You have to use the same name. Suppose your name is the longitude, just you put here the longitude also in here. Your name is the latitude in your CSV file, just put here the latitude and then upload. Okay, so this is the process. Suppose I take the training sample for agricultural land. So simply you can make the CSV file for agricultural land, which you including all of latitude, longitude value for CSV file, and then simply import, and then also take the add property and put the class and put, suppose agriculture, I put here the 1. Okay, then upload. The same process, also put the X column, Y column and upload. And when you upload it, you can easily get it from your asset tab, and from the asset tab simply just click on here, then it will be imported in your Earth Engine code editor. And further, simply we are just you merge all of training sample together. Okay, so this is the process for working with ground truth data. Yeah, please.
No, I just think, thank you.
When you said that latitude and longitude, so that is for every single point there will be a separate latitude and longitude. So each CSV file will contain only one data point.
No, it's the multi
Like
data
one
point.
geometry point.
Okay, multi point. We have to take the multi point. Okay, for multi latitude, longitude value, multi point for water, for cropland, for vegetation. Okay, then simply single by single we upload it in Google Earth Engine and then import it from the asset tab. Okay, then you can also work with that.
Okay.
Then apply the same process, just to simply merge. Okay, and then this is my training sample. Here we find out the total, how much you can see, we find out the total 189. Okay, and every data has a pre-categorized. We set the level. Okay, we set the level. So basically the pre-categorized one is for cropland. Okay, we already make the pre-categorized, just add the level. So now all of training points, I extract the band pixel value. Okay, I extract the band pixel value. So now I just make the, so these are fifth step. Fifth step, we are just extract the bands value. So band values we simply extract from each point. Suppose this point, it extract the band pixel value. So now which band I want to use in this time? For the different purpose, we are using the different types of band. So normally, suppose I want to use all of band. Suppose just take a variable band and I make a list. Just make a list, all of bands list, square bracket. and put here the band name. So here you can see, here we find out the some band is the 60 meter, some band is the 10 meter and 20 meter. So I want to use only for the 10 meter and 20 meter band. Okay, 10 meter and 20 meter band. I ignore the 60 meter band, it's not need. Okay, so I want to use the 10 meter and 20 meter band, all of band I want to use for 10 meter and 20 meter. So just put in here in your, just the list I put in here. Suppose B2, then B3, then B4, then put here B5, B6, B7, then B8, then B8A, B11, short wave infrared 1, and also put at the B12, short infrared 2. So basically this type of band I want to use to extract the band pixel value. Each point, all of point, extract the all of band pixel value and make a data set. Okay, so let's go try to extract the band pixel value for all of training sample. So for that, take a variable, suppose training, and call the image and select all of band which is stored in this variable. Copy and paste here. And use at the sample regions function. Okay? And put all of argument one by one. So just make a curly bracket start. And also curly bracket int. And collection mainly it's my training sample or training point. So just copy these samples and paste here. Then properties mainly it's our property name. So here you can see all of classes we have the same property which is class. Okay, so just put here the properties name as a class. So scale, I want to extract the pixel value, consider the 10 meter pixel size area. Projection not need, remove that. So now if I run the code and print the training, just print this training. So all of training points extract the all of bands pixel value. Okay, B2, B3, B4, all of bands extract each single point. Okay, every single point extract. You can check it from the feature. So here you can see it extract the band pixel value. Just click on here and check the properties. Here we find out that all of band pixel value for this point B11, B12, B2. Okay, and also what is the class? Class is the 0. This is our level. This is our level, and this point extract all of band pixel value. So every single point extract the band pixel value. Every single point extract the band pixel value. Here you can see. Okay, but it extract only for those band which are available in here. Okay, but in my model I want to add the more band. Suppose I want to add the NDVI band, mainly normalized difference vegetation index band. So what can I do for that? So NDVI band, when you want to add, then it also extract the information for NDVI. So let's go at how we can easily add the external band. Okay, so which bands are not available in my satellite imagery, but this band I also use and extract the information for each single point. So for doing the band, suppose I want to add the new band of NDVI. So let's go try to add and then check what happened. How I can add the external band. Okay, for adding the external band, we are just applying the same process. We are just creating a function. Okay, so I just add the external bands. So for doing this thing, just take a variable. Suppose add band, and then just make a function. Put the element name, suppose image, and then put the take a variable, suppose NDVI, I call the image and normalize difference between